Hi, my name is Afiq and my ID number is 2020815234.
Hi, my name is Amirah. My metric number is 2020472674.
Assalamualaikum and hi, my name is Nurul and my student ID is 2020494178.
Hello, hi, Assalamualaikum. My name is Batrisyia Adriana binti Mak Farouk and my student ID is 2020809368.
Hello there, Afiq here, and today our group would like to present to you about one of the topic in the application of differentiation, which is related rate. Related rate is to compute the rate of change of one quantity in terms of rate of change of another quantity which may be more easily measured. Related rate is often used by a scientist and engineer. The method of related rate have a broad application in this field. How do we solve related rate exactly? The first thing is you need to read the problem carefully and draw a diagram if possible. After that, we need to introduce notation. Assign symbol to all quantities that are function of time. Then, we have to express the information and the required rate in terms of derivatives, and write an equation that relate the various quantity of the problem. Then, use the chain rule to differentiate both sides of the equation with the respect to the t. Lastly, substitute the given information into the resulting equation and solve for the unknown rate. Errors in this procedure are often caused by plugging in the known value, the variable before finding the derivative respect to time. Doing so will yield an incorrect result, since if those values are substituted for the variable before the differentiation, those variables will become constant. And when the equation is differentiated, 0 will appear in the place of all variables for which the value were plugged in.
Next, I will show you an example so that we can understand it better. Let's see what to solve. Flour is poured into a conical pile at the rate of 25 cm³ per min, whose bottom radius is always half the height. How fast will the area of the base be increasing while the pile is 50 cm height?
First step, you need to list down all the information given. It's given that the dV over dt is 25 cm³ per minute and radius is always half the height, which is r equal to 1/2h. The question asked is to find the dA over dt when h equal to 15 cm. The formula we can use is dA over dt equal to dA over dh times dh over dv times dv over dt. For the second step, by using formula volume cone, differentiate the function. The formula for volume cone is 1/3 by r square h. Substitute r into the formula volume cone. Then, differentiate by using quotient rule method, vu prime minus uv prime over v squared. So, you will get the dv over dh equal to pi h over 4. But, we need to find dh over dv. So, it becomes 4 over pi h. Next, we need to find the dA over dh. To solve this, you need to differentiate the area of cone. the formula for area cone is pi r square plus pi rh. Then, differentiate the equation with substitute r into the formula and you will get dA over dH equal to pi h plus pi h over 2. The last step, solve the required question. Use the formula of dA over dt equal to dA over dH times dH over dV times dV over dt. For dA over dH is pi h plus pi h over 2 times dH over dV 4 over pi h times dV over dt 25. Solve the equation by substitute h for 15 and you will get the answer is 150.195 cm³ per minute.
Related rates problem are applied problem where we find the rate at which one quantity is changing by relating it to other quantities whose rate are known. Related rates problem are known for their real-life application, but just how real-life are they actually? Nobody has the desire to calculate the rate which ladders fall or a balloon is blown up. But one thing to recognize is that while math has theorem and rules to live by, there is also conceptual pieces that play further than the math itself. Related rate is something seen every day as a concept, not just a mathematical function.